Hello dear students, myself Ganga Bhosle, your statistics teacher. Today we are going to learn example of Poisson distribution, that is example number 3. The first proof of 200 pages of a book containing 560 pages revealed the following distribution of the number of printing errors. Here in this table given that some exercise values and their respective FI's values, that is number of errors in a page which is represented by XI values and number of pages which represent FI values. And here we have to fit a Poisson distribution corresponding to this data. And here also given that e raised to minus 0.605 is equal to 0.546. Okay. Now, for the solution, first we have to find out mean, that is value of m. For this, we first find out average, that is average number of errors, average number of errors for page. So, here we have to find out summation Fi Xi divided by summation Fi, which is equal to summation Fi Xi, that is 0 into 112. First 0 into 112 plus 1 into 63 plus 2 into 20 plus 3 into 3 plus 4 into 1 plus 5 into 1 and whole divided by summation Fi, that is 112 plus 63 plus 20 plus 3 plus 1 plus 1. 112 plus 63 plus 20 plus 3 plus 1 plus 1. 0 into 112 is equal to 0. Then 1 into 63 is equal to 63 plus 2 into 20 which is equal to 40 plus 3 3s are 9, 4 1s are 4 plus 5 1s are 5, whole divided by 112 plus 63 plus 20 plus 3 plus 1 plus 1 which is equal to 200, and summation of numerator, that is 63 plus 40 plus 9 plus 4 plus 5 which is equal to 121 divided by 200. When we divide 121 by 200, we get 0.605. This is nothing but our value of m. So, here we get m is equal to, that is NP, which is equal to 0.605. Okay. Here we have to find out number of pages having 0 error, 1 error, 2 error, 3 error, 4 errors, 5 errors. Okay. First we find out number of pages having 0 error, Here I am writing the formula of Poisson distribution, that is e raised to minus m, m raised to x divided by x factorial. But here we are given the respective Fi values, that is here we have to multiply capital N which is equal to summation Fi, and the value of summation Fi is 200. So, we have to multiply it by 200. Okay. That is 200 into, for here x is equal to 0. So, we get e raised to minus m, that is minus 0.605 into m raised to 0 divided by 0 factorial, which is equal to 200 into e raised to minus 0.605, which is given that 0.546. 546 into m raised to 0 is equal to 1 and 0 factorial is equal to 1. So, we get 200 into 0.546 is equal to 109.2. Then similarly, we find out number of pages having one error, that is here the value of x is 1. So, we write here 200 into e raised to minus 0.605 into m raised to 1, x is equal to 1. So, here we get m raised to 1 divided by 1 factorial, which is equal to 200 into the value of e raised to minus 0.605 is 0.546 into the value of m. What is the value of m? Here 0.605, 0.605 divided by 1 factorial, which is equal to 1. So, when we multiplied 200 into 0.546 into 0.605, here we get 66.066. Then number of pages having 2 errors, that is here the value of x is 2. So, here 200 into e raised to minus 0.605 into m square divided by, that is m square is, what is the value of m? 0.605 raised to 2 divided by 2 factorial, which is equal to 200 into the value of e raised to minus 605 is equal to 0.546 into 0.605 its square divided by 2 factorial, which is equal to 2 factorial is 2, and when we calculate all these terms we get answer 19.985. Okay. Now, for x is equal to 3, that is number of pages having three errors, which is equal to 200 into e raised to minus m, that is e raised to minus 0.605 into m cube. The value of m is 0.605 raised to 3 divided by 3 factorial, which is equal to 200 into the value of e raised to minus 0.605 is 0.546 into 0.605 raised to 3, and the value of 3 factorial, that is 3 into 2 into 1, which is equal to 6, and when we calculate all these terms we get answer 4.030. In the same way, we calculate number of pages having 4 errors. Number of pages having 4 errors. So, here the value of x is equal to 4. which is equal to 200 into e raised to minus 4, e raised to minus m, that is 0.605 into m raised to x, that is 0.605 into the value of x is 4 divided by x factorial, that is 4 factorial, which is equal to 200 into the value of e raised to minus 0.605 is 0.546 into 0.605 raised to 4 divided by 4 factorial, that is 4 into 3 into 2 into 1, which is equal to 24. When we calculate this, we get answer 0.609. Okay. Now, we calculate number of pages having 5 errors. Number of pages having 5 errors, that is x is equal to 5, which is equal to 200 into e raised to minus m, that is 0.605 into m raised to, that is 0.605 raised to x, that is 5 divided by x factorial, that is 5 factorial, which is equal to 200 into the value of e raised to minus 0.605 is 0.546 into 0.605 raised to 5 divided by 5 factorial, that is 5 into 4 into 3 into 2 into 1, which is equal to 120. And the answer, that is number of pages having 5 errors is 0.073. Okay. Now, you see example number 4, that is based on past experience, it is assumed that the number of flaws per foot in grade 2 paper follows Poisson distribution with an average of 1 flaw per 5 feet of paper. Then what is the probability that in a 1 foot roll there will be at least 2 flaws, and second one 12 foot roll there will be at least 1 flaw. First, similarly here we have to find out m, that is mean. So, for this we calculate average number of flaws in 1 foot of paper, which is equal to, here there is a 5 feet of paper. So, we get average number of flaws in 1 foot of paper is 1 by 5, which is equal to 0.2, that is m is equal to 0.2, and for average number of flaws in 12 foot of paper is equal to, so we have 1 by 5 into 12. We have to calculate 1 by 5 into 12, that is number of flaws in 12 foot of paper. 1 by 5 into 12 is equal to 2.4. This is also a mean, that is m is equal to 2.4 for 12-foot roll. Okay. First we calculate 1-foot roll, there will be at least 2 flaws. Here I am writing required probability that 1-foot roll there will be 1-foot roll there will be at least 2 flaws. Here we have to find out at least 2 flaws. So we have to find out probability for x is equal to 0, for x is equal to 1, and we have to subtract from this from 1. So 1 minus p of 0 minus p of 1, that is for x is equal to 0 and x is equal to 1, which is equal to 1 minus, here the value of x is equal to 0. What is the formula of p of x is equal to Poisson distribution, that is e raised to minus m raised to x divided by x factorial, that is e raised to minus m. For 1-foot roll their average is, that is m is equal to 0.2, e raised to minus 0.2 raised to 0, that is the value of x divided by 0 factorial, minus e raised to minus 0.2 raised to, the value of x is 1 divided by 1 factorial, which is equal to 1 minus e raised to minus 0.2 into 0.2 raised to 0 is 1, 0 factorial is 1, minus e raised to minus 0.2 into 0.2 divided by 1 factorial, which is equal to 1, which is equal to 1 minus e raised to minus 0.2 minus 0.2 into e raised to minus 0.2, which is equal to 1 minus, from this equation we common out the value e raised to minus 0.2, e raised to minus 0.2. So here we get 1 plus 0.2, then 1 plus 0.2, which is equal to 1.2. So here we get 1 minus 1.2 into e raised to minus 0.2. Then calculate here probability of 12-foot roll, there will be at least 1 flaw. Required probability that 12-foot roll there will be 12-foot roll there will be at least 1 flaw, at least 1 flaw. So here we have to calculate 1 minus p of 0, that is x is equal to 0, 1 minus e raised to minus m raised to x divided by x factorial. But for this here we have average, that is mean, for 12-foot is 2.4. Here we write e raised to minus 2.4 into m, that is 2.4 raised to 0 divided by 0 factorial, which is equal to 1 minus e raised to minus 2.4 into 2.4 raised to 0 is 1, 0 factorial is 1. So, here we get final answer 1 minus e raised to minus 2.4. Okay. I hope all of you understood these two examples. In next lecture, we learn more examples with respect to Poisson distribution. Okay. Thank you.